embark on an exciting journey to become an embedded software engineer. As our world becomes increasingly populated with smart devices ranging from IoT gadgets to sophisticated automotive systems and extending to medical equipment and consumer products, embedded software is essential in shaping the technology of today. Welcome to CocoVat. Today, we will break down the roadmap into two clear stages of learning. We will explore the foundational skills needed to begin your journey and then develop into more advanced competencies necessary for a career in industries that rely heavily on embedded systems. Let's start by looking at some foundational skills needed for an embedded software engineer. The most important skill you will need is C language. It's a powerful and flexible programming language, especially popular in the world of embedded systems. You might wonder, with so many programming languages out there, why C? Well, here are the top 5 reasons why C is the go to language in embedded systems. Controller or processor independent. Imagine you have designed a product using an ARM controller. Now, if you decided to switch to a PIC microcontroller, it's easy to do that with C. C is a hardware independent, meaning you can reuse most of your existing code even if you change the hardware. This is possible because embedded systems are usually organized in layers: hardware layer, interaction layer, service layer, application layer with C. You can make hardware changes without affecting the rest of the system, saving both time and effort. Portability. One of C's best feature is portability. It means that the code written in C can be compiled and run on different platforms with minimal changes. This is great because if you ever need to switch compiler during development, you can do so with very little adjustment. This makes C very efficient, easy to maintain, and even easier to debug. Performance. When you use languages like Python, your code need to go through an interpreter, which means another layer of software has to read and run your program. C, however, is a compiled language, which means your code gets directly translated into machine language that the hardware can understand and execute right away. This makes C program run faster and more efficiently. Bit manipulation. Bit manipulation is when you directly control individual bits of data using bitwise operators. This is extremely useful in scenarios like controlling hardware or optimizing memory usage. For example, if you want to turn a specific LED on or off in an embedded device to indicate an error or status, a bitwise operations let you do that without interfering with other features. This makes it a great tool for efficient low level control in embedded system. Memory management. C allows you to have direct control over memory by enabling you to read from and write to specific addresses using pointers. You can manage memory in two ways: dynamically, when you are unsure of the amount of memory required, or statically, when you know the memory needs in advance. This flexibility is particularly valuable in embedded systems where memory is often limited. With C memory management capabilities, you can optimize the use of available resources, ensuring your system runs as efficiently as possible. Resources. If you're just getting started, there are great resources available for learning C. You can check out online courses on platforms like Coursera, Udemy, or read classics like The C Programming Language by Kernighan and Ritchie. If you're new to programming, C for Dummies is also a great way to get solid understanding of the basics. As an embedded software engineer, it's crucial to understand basic digital and analog electronics concepts as they directly influence how you interact with hardware. You need to be familiar with voltage, current, and resistance, which describes how electrical charge flows through circuits. You should also understand the difference between digital and analog signals. Digital signals represent binary data, zeros and ones, while analog signals vary continuously. Logic gates like AND, OR, and NOT are fundamental for decision making in circuits, and transistors act as switches or amplifiers for controlling current. Components like capacitors and inductors help manage energy, stabilize power, and filter signals, while resistors controls current flow and potentiometers allows for adjustable resistance. A solid understanding of power supply and grounding is essential for proper circuit operation. Additionally, knowing how to use communication protocols like I2C, SPI, and UART allows you to connect embedded systems to sensors, actuators, and other devices. Lastly, tools like multimeter and oscilloscope are vital for troubleshooting circuits and ensuring everything works as expected. Mastering this concept will help you design, debug, and optimize embedded system effectively. With a solid foundation in C and basic electronics, you are now ready to dive into hands-on projects with Arduino. Don't wait any longer. Order your Arduino board and start experimenting with simple projects to build your practical skills. Begin with a classical LED blink project. Move on to turning on a mini fan based on temperature or lighting up a bulb using a motion sensor. You can also try building a homemade clock using an RTC module or even create an electronic locking system with RF cards. If you have any other project ideas in mind, go ahead and explore. This project will not only reinforce your understanding but also ignite your creativity in the world of embedded systems. And that wraps up the foundation level. Stay tuned as we move on to the advanced level.